Welcome back to Chem 330, week 1. And previously I told you all how to write a name for a organic compound, and particularly an alkane, right? Now, we did do a few practice problems in class, and while the information I gave you was pretty good for most organic compounds that are alkanes, there's still a few tips and tricks that you can use when you encounter compounds that don't quite fall under the radar. Okay, what do I mean by that? All right, and this was one of the compounds we did work out in class, and while some of you were able to do it, some of you had difficulty, and so I'm going to walk you through 2 or 3 different compounds in this particular video, where I'll walk you through what would you do if you run into those problems. Okay, all right, so with that said, this is the compound that was one of the practice problem on the worksheet. And the first thing you do when you name any compound, whether it's alkane or some other compound in the future that contains carbon, is first you got to figure out the longest chain. Okay, figure out the longest chain. Okay, now there's multiple ways you can do it, and conventionally I would highly recommend that you go for the straight chain. Okay, so look for the straightest possible chain. And this is not always going to be the case. Okay, in this case it works out that this is one of the routes, and how many carbons do I have there? Okay, 8 carbons. Okay, let's pick a different color just to see if we can get more carbons than what we have now. All right, so with that in mind, okay, okay, okay. Okay, I think I lost connection just for a brief period of time. So let's say you run into a compound, say we go this route, okay, and we have 8 carbons there as well, right? So it really doesn't matter in this case which route do you pick. I mean, since they both have 8 carbons, doesn't matter which one you pick, you're going to end up with the same name in the end. Okay, so with that said, I'm just going to go with this particular chain right here. Okay, now the next question you have to ask is, where should I start the numbering from? Okay, these are the questions you should ask. Where should I start the numbering from, right? All right, to answer that question, in this particular case, I could go too technical and confuse you all, or keep it simple and help you understand the concept. All right, looking at this molecule holistically, okay, visually just looking at it, which side do you think there's more weight? What do I mean? Just imagine the molecule to be a seesaw. Okay, looking at this molecule as a seesaw, which side do you think there's more load or more weight? Okay, clearly you see that. I'm just gonna mark this side right here. Clearly this whole side is pretty heavy, right, compared to the other side, right? You don't need to make a perfect distinction, but if you can visually distinguish between 2 areas of the molecule, then there should be no problem. Okay, which leaves us, you start numbering from the side that's pretty heavy. Okay, you start numbering, okay, from the side, okay, okay, with large load. I'm just going to call it large load, and you can treat it as more number of, or more carbons, more number of carbons, right? With that thought in mind, let's bring back our image again so we can actually number it. Okay, very good. So let's go get our black. Now what that means is I pick this row, okay, the straight chain, so I start numbering from here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and we have established in our first video for numbering that this group right here is known as a propyl, right, and this group is a methyl. Okay, so that means, and when you start to actually number, when you start to write the name, alphabet takes precedence. Okay, so this starts with P, this starts with M. So in the name that you're going to write, M takes precedence over propyl because M comes before P on A through Z, right? Now there are 8 carbons total, so the last name for this compound is octane, right? Right, 8 carbon is octane, right? So that's the last name. Now we got to go get our first and middle names, so to speak, and the propyl group is located at 4 and the methyl group is located at 6, right? So it's 6 methyl. You would have thought you would write 4 propyl first, but P comes after M, so 6 methyl 4 propyl octane. That's the name of the compound right here. Does that make sense? So the thing here is, first you got to figure out the longest chain, and then you have to figure out which side is heavily loaded or looks heavy just visually. If you want to treat this like your C's are right here, right in the middle, well, which side's got more weight? Clearly this side. So you start numbering from the side that's got more number of carbons or a large load, right? And then you also have to pay attention to which letter takes precedence over another letter, right? So 6 methyl 4 propyl octane is your name of this particular organic compound. Now let's go get one more compound that was also a little tricky, and I believe that was actually this compound right here. Okay, this compound right here, compound number 6. So I'm going to get this compound and then get this to our working space. Okay, this is a little tricky, perhaps even an unusual looking compound. Okay, okay, all right, we got our compound in. Now people that created this compound probably purposefully created it this way so that they want you to be confused. Now you can ask, why do they want you to be confused? Maybe they expect you to learn it at a higher level. All right, so as I said, your first job is to figure out the longest chain. Okay, so I'm going to use multiple colors here. So let's say you want to start here, okay, and you can call this is one of your chains, and if you see there are 8 carbons in this route. If say you want to take this route, that would give you 8 carbons. Let's go get another color, okay, and say let's go straight this time. See if we can beat that number. Well, unfortunately, I'm actually getting less, so it's 7 carbons. Okay, let's go get one more color, see how many different ways we can sort this out. So let's say I want to go this and just go down straight. That still gives me 7 carbons. Okay, there might be another route that would give us more colors. So let's go get maybe a red, thick red. Okay, in that case, you notice if I go straight and curve back and go back to where I started, I get 10 carbons, right? So that is my longest chain, right? So let's bring back the compound one more time, just like we did earlier. Okay, now all this is just playing around with the molecule, right? So now we figured out what our longest chain is. The next thing is we have to figure out where to start numbering, right? Now if in this case, looking at it and see which side is loaded more, yeah, you can tell, right? It's clearly the side on the bottom is anything to, okay, if you call this your C sub point, okay, okay, I guess let me erase that. Okay, okay, right? here you can use the rule I even suggested earlier, which is, well, we know now these two are our substituents, right? And they are hanging off this carbon, right? And if you look to the side of the carbon containing the substituents, there's 4 on this side, there's 5 on this side, right? And I told you earlier when I taught you how to name compounds, you start numbering from the side that has the least number of carbons, right? Now don't confuse this with that heavyweight thing, because this is a little bit tricky for the heavyweight thing, because you don't know where to put that CISA symbol. That's why I erased it. Okay, so we're going to revert to our classical method of learning it. So this is 4 and 5, so we start numbering from here. So let me get my trusted black color pen. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right? Now we know it's 10 carbons. Okay, 10 carbons is decane, right? So that's our last name for the compound. Okay, and we know this right here is an ethyl group and this right here is a methyl group, right? Good. So that means E takes precedence over M, so it'll be, it's all in the same 5th carbon, so 5 ethyl, 5 methyl decane. That's our name. Let's look at one more compound. While most students didn't really find it difficult per se, they were able to do it, but visually they had a problem with it. So let's go get that compound. I believe it was in this one. You're looking at that compound 7. Let's get that compound, get it to our paintbrush. Okay, let's get this compound back to our workstation. Okay. Okay, these are the 3 compounds I really want to take the time and go over with you. Okay, now this is pretty straightforward. No matter how you cut it, this chain right here is my longest chain, and if I count, there's 4 plus 3, 7 carbons total, and 7 carbon is a heptane. Okay, heptane. So heptane is the last name of my compound. Okay, now where do I start numbering from? Well, again, there's too many methyl groups and visually it could confuse you, right? Look at it visually and see which side is the CISA, like put a CISA right in the middle and you see which side has kind of extra load is this side, right? So we should start numbering from this side. So it will be 1, 2, 3, 4, 5, 6, 7, 8, right? So we have 1, 2, 3, 4, 5 methyl groups, right? 5 is penta, right? 5 is penta. So that means we say 2, 3, 4, 5, 6 penta methyl heptane, and that's it. All right, so these are the 3 compounds students had a little bit of difficulty getting the right answer, and if you follow along the video, you should be able to name any alkane. No matter how complicated it looks, you should still be able to name them. All right, stay tuned for week 2 and week 3 videos. Bye bye.